Hey everyone, in this lesson we are going to do some intro to polar graphing notes. So we're going to focus today specifically on graphing polar coordinates as well as converting from rectangular to polar coordinates. All right, so we're used to graphing in the Cartesian plane with our xy axis. Those are our rectangular coordinates. All right. The polar coordinate system is simply a point O, and that is called the pole or the origin, and a ray called the polar axis. All right, we plot points in the polar coordinate system using polar coordinates, where r is that directed distance from O to some point P, and theta is the directed angle from the polar axis to point P. So our coordinate, if you can't see that, that says P equals r theta. So we're going to graph some examples here. Okay. Now, with this particular picture, it's actually broken up into pi over 12s. So this is your pi over 6. Here's your pi over 4. Here's your pi over 3. Okay, so if we have p at 3 and then pi over 3, we're going to go to our pi over 3 angle, and then we're going to count 3 circles away. So 1, 2, 3 circles away. There we are. There's p. Okay. Then for negative 5, 3 pi over 4. So this, we'll go to our 3 pi over 4 angle first. So that's going to be right here. Now, because of the negative 5, that means we're going to go in the opposite direction. So it's going to reflect itself, okay, to this side. So we're going to count 1, 2, 3, 4, 5, and that's where point Q is going to go. Okay, so if you have a negative, either if you have a negative r, that's going to change the side of the angle that you're on. And then we've got r at 8, negative 60. So first of all, negative 60, that's negative pi over 3. Okay, so remember, negative angles, we go clockwise, so that'll put us here, and then we want 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's where it would be. There is your coordinate r. So I want you to go ahead and try these next 3 on your own. Pause the video, try them, and then press play when you're ready. All right, so point C is at 6, 120. 120 is the same as 2 pi over 3. So we're going to go to our 2 pi over 3 angle and then count 1, 2, 3, 4, 5, 6. So that would put point C at that coordinate. Then we've got 4 and negative 5 pi over 6. So we're going to go to negative 5 pi over 6, which is here. And then we're going to go out 4. So 1, 2, 3, 4. Puts us right there. There's point G. And then S, we've got negative 3 and negative 2 pi over 3. So we're going to go to negative 2 pi over 3 first, which would be right here. All right, but then we have a negative r, so we know it's going to reflect it across. And again, we're going to go out 3. So 1, 2, 3. That's going to put us right here. So there's S. Now, there are various ways to name the same point. So I've given you the example 6, 120. Remember, 120 is the same as 2 pi over 3. So another way to write that, okay, would be to keep the 6, and instead of 2 pi over 3, we could do negative 5 pi over 3. That's a coterminal angle. Okay, so that's another way to write it. Okay, another way we could write it is we could make the r negative, and our angle could be, say, negative 2 pi over 3. Okay, so if you go negative 2 pi over 3, but then you're going to have to reflect over, that will put you in the same location. All right. Another way you could write it would be -6 and +5 pi over 3, which is the same location as -2 pi over 3. So there's some extra ways that you could write the same coordinate point. All right, so now we're going to talk about rectangular and polar coordinates and their relationship. All right, so you have this little first quadrant picture here. Your pole is at the origin. You have a side that's x units long and a side that's y units long. So if you think back to Pythagorean theorem, you've got x squared plus y squared is going to equal this side r squared. This is also, if you had a circle here, the center would be at the origin, the radius is r, so you could have a circle with radius r there. So r squared equals x squared plus y squared. Now, our definitions of trig functions, we should already know these. On the unit circle, our r was always 1, so that's why we said sine of theta was our y value, because we were dividing by 1. Now we're going to say sine of theta equals y over r, which is our opposite over our hypotenuse. Cosine, adjacent over hypotenuse, so x over r, and tangent, opposite, which is y, over adjacent x. Okay, so based off of those, we can convert. So cosine of theta, we just said, is x over r. So if you multiplied by r, that means x equals r times cosine. Same thing with sine. If we multiply by r, y equals r times sine of theta. And tangent is y over x, and we know that that's r squared equals x squared plus y squared. That's our Pythagorean identity. All right, so we're going to convert the point 4 comma negative pi over 3 into rectangular coordinates. So remember, this is my r and this is my theta. I should put them below, r and theta. Okay, so, and according to what we just wrote out, x equals r times cosine of theta, and y equals r times sine of theta. So our r is 4, and then we have to have cosine of negative pi over 3. So the cosine of negative pi over 3 is 1/2, and 4 times 1/2 is 2. Over here, we've got 4 times the sine of negative pi over 3. The sine of negative pi over 3 is negative square root of 3 over 2. When we multiply that by 4, both these are divisible by 2. So that'll leave us with -2 square root of 3. So our coordinates are 2 comma -2 square root of 3. Go ahead and try those next two on your own, and then press play when you're ready. So here's my r, here's my theta. X equals r times cosine of my angle. Y equals r times sine of my angle. Cosine of pi is -1. 2 times -1 is -2. And then sine of pi is 0, and 2 times 0 is 0. So our rectangular coordinates there are -2, 0. All right, then we've got the square root of 3 and comma pi over 6. So x equals the square root of 3 cosine of pi over 6, and then y equals square root of 3 times sine of pi over 6. So cosine of pi over 6 is square root of 3 over 2. So we're multiplying square root of 3 times square root of 3 over 2. Square root of 3 times square root of 3 is just 3, so that becomes 3/2. Sine of pi over 6 is 1/2. So square root of 3 times 1/2 is going to be the square root of 3 over 2. So our coordinates there are 3/2, square root of 3 over 2. All right, so now we're going to go from a rectangular coordinate into polar coordinates. All right, so one is my x value and one is my y value. So we're going to use the tangent conversion here. So we know tangent of theta equals y over x. Okay, excuse me, when will tangent equal 1? that's at pi over 4 and 5 pi over 4. So it could either be pi over 4 or 5 pi over 4. We don't know which because, oh, well, actually we do know which. 1, 1 is in the first quadrant, so it's just going to be pi over 4. Sorry about that. So now we've got our theta. We just need to figure out our r. Okay, so we're going to use the Pythagorean identity, x squared plus y squared equals r squared. So we've got 1 squared plus 1 squared equals r squared. 1 plus 1 is 2. And then we're going to square root. So r is the square root of 2. So square root of 2, comma, pi over 4 is our problem. All right. Then we're going to convert each of the following again into polar coordinates, so you can pause and try this yourself. So we've got tangent of theta equals y over x, so 1 over negative 1. That's going to get us an answer that's negative 1. So when is your y positive and your x negative? That's in second quadrant. So our angle is going to be 3 pi over 4. All right, and then we've got negative 1 squared plus 1 squared equals r squared. 1 plus 1 is 2. And r is going to be the square root of 2. So our coordinate is square root of 2, comma, 3 pi over 4. All right, and then the last one, 0, 2. So tangent of theta equals y over x, which is undefined. Okay. If the y is positive, but the x is 0, that would be at pi over 2. So theta equals pi over 2. All right, then x squared plus y squared equals r squared. So we get 0 plus 4. Square root of 4 is 2. So our coordinate is 2 pi over 2. And that's graphing in the polar coordinate system and converting.